Okay, for problem number 29, when we choose 95% confident interval, which of the following will change? Well, if we are going to go from a 95 to a 90, then it gets narrower because we are less confident. Means a narrower confidence interval. For problem number 22, they want to make a 95% confidence interval with a margin of error of 0.25. So margin of error, and we always round these up, is equal to z star square root 0.5 times 0.5 over n. So I'm going to do inverse norm 0.025 with a mean of 0 and a standard deviation of 1, which gives me 0.96. 0.25 over n equals 0.05. This is an n right here. So I am going to divide both sides by 1.96. And so 0.5, when I take the square root of this, it's 0.5 over the square root of n equals a really low number. 0.05 divided by 1.96 is 0.0255. If I multiply by the square root of n and then divide by 0.0255, I get the square root of n is equal to 0.5 over 0.0255, and I'm just going to keep the number in my calculator, and then I'm going to square both sides. So 0.5 divided by my answer, and then squared it, n equaled 384.16, which I then round up to be 385. In problem number 23, 0.25 is in the interval, which means that I'm going to fail to reject at the 0.05 level. 24, we have a positive since it's r equals 0.78. We know that there's a positive and that it is strong. We don't know if it's linear or not linear until we figure out what's going on. 25, if we get rid of the outlier, the correlation becomes stronger. And really there's not going to be much change to the equation. It's just going to look more like a line. And one last problem. We are which the least square regression line minimizes what? That would be the squares of the residuals. And if you remember what the residuals are, they are the expected, I'm sorry, not the expected, the actual minus the expected. So if you square those, then that's what you get when you want to minimize. So that's it for the review.